doubt for that procedure? This is your, so before starting that problem, you can set your null hypothesis and alternative hypothesis in this way. Okay, so this is your formula, same formula, goodness of fit and as well as then that means independence of attributes. Both are having the same formula. So any doubt? Only thing is, previously goodness of fit we have the degrees of freedom is n minus 1, where that n represents sample size. Here with the degrees of freedom m minus 1, n minus 1. Okay, so your m is the number of rows and n equal to number of columns. So any doubt for this procedure? Then we move on to that other thing.
No, sir.
Hey, anyone? No. Okay. So next. Okay. One shortcut is there. Actually, so how to compute that value now? You can prepare one column. You can prepare the given observed frequency. So we have to calculate respective expected frequency of the given observed frequency. Then third column you can prepare in that way, O minus E whole squared by E. Okay. So finally you can put the total, that is your calculated value. In that way we are computing chi-square value for goodness of fit. Okay. But here one shortcut is there that I will explain. Because in most of the problem, only 2 rows, 2 columns are given. That time we can compute in the shortcut way. Okay, one is there 2 by 2 contingency table. Actually, the given data we have 2 attributes A. So there are 2 attributes A and B. Okay, so here that categories are given. Okay, for example, here alpha 1. For example, okay, 2 kind of categories. For example, here we have educator. So non-educator. Okay, here smokers, non-smoker. Okay, for example, I'm telling. Okay, so we have 2 attributes. In that way is given. Okay, so therefore the question asking, is there any relation between the smoking habit with respect to the education? Okay, so is there any independence relationship between the education and smoking habit? So that is the question asking. Okay, so therefore always here the 2 attributes are A and B are independent. Okay, but here we have the data A, B, C and D. Okay, so here how many rows are there? 2 rows and 2 columns are there. Okay, so 2 rows and 2 columns are given in the data. Okay, so this kind of data is given in the problem. We have 2 rows and 2 columns. Now you can compute your value in the easy way. Okay, so how to compute that now? Okay, so we have the data, we have A and B, C and D. Okay, so 2 rows and 2 columns are there. So now you can immediately you can find out your total of this that one. Okay, so here also you can compute your total. Okay, so how to compute that? Okay, in the third column represents total. Similarly, here third row represents total. Okay, so now you can put row wise total A plus B. Okay, then C plus D. Okay, next one you can compute your column wise total A plus C and B plus D. Okay, next you can compute the grand total. Either you can adding row way, column or row. What you are getting? So we have the attributes A, B and C and D given in the data. Now you are computing total, row wise total and column wise total. So what is your row wise total? A plus B, C plus D. Column wise total is A plus C and B plus D. So now that this space represents, that is grand total. Okay, So what is the grand total of that one? Either you can add row wise, column
A
wise.
plus
What you have to get?
B plus
Yeah,
B plus C plus D.
A plus B plus C plus D. That you have to take that represents n. Okay. Now immediately you can write your chi-square value in that way, in that manner. Very simple. So no need to prepare the table. One column is observed frequency, another column expected frequency. Next you got to compute. You can apply that shortcut formula. So which one is easy? You can follow that one. Okay. So chi-square. But my suggestion is this one is very easy for computing your chi-square value. The given data we have 2 rows and 2 columns. Okay. How to write the numerator? That is n. So what is n? That will be represents a plus b plus c plus d. N into in numerator, you know, matrix multiplication. So that is a determinant. We have 2 ab cd. Okay. So how to express your determinant? You can multiply that one a into d. Okay. That you have to write here a into d. Okay. Next you can, this is a into d. Next you can multiply b into c. Okay. So if you are expressing the determinant in that side now, you can get ad minus bc. Okay. So a into d, then minus b into c. That you have to find out. You can put to the square. Okay. N into ad minus bc whole square. Your denominator is nothing but row wise total a plus b and c plus d, and also column wise total a plus c, then b plus d. Okay. So b plus d. In that way you are computing your calculated value for chi-square. Okay. So that is important. So we have the data a b c d that is given in the problem. You can put row wise total and column wise total. Okay. So you can prepare this kind of data. After that you can write chi-square value equal to, so capital N is nothing but you can adding, that is your grand total of that one, all the values, grand total of all the values. So n into, then you can express in the determinant in the form ad minus bc whole square divided by a plus b c plus d a plus c b plus d. So in that way you can computing your chi-square value directly. Okay. So here degrees of freedom is same thing. What is your degrees of freedom? M minus 1, n minus 1. So therefore m minus 1 means here 2 rows and 2 columns. 2 minus 1, 2 minus 1. That is nothing but 2 minus 1, that is 1. Here also 2 minus 1, that is none. So therefore you look at your table value at degrees of freedom 1. Okay. So this is clear, pa? So if you have any doubt for this shortcut formula?
No, sir.
Okay.
No, sir.
But 3 rows, 3 columns are given, you can compute in the direct way. Okay. So this is a shortcut way for 2 by 2. So 2 rows and 2 columns. Suppose we have 3 rows and 3 columns now, we can use the formal method, that is the goodness of it method. One column you can prepare observed, another column you can prepare expected frequency, then you can compute the other things. Okay. So both of the problems discussed today. So if you are copied now, then I have to rough things. Copied over. If you are copied now, then you can tell. So I have to rough the board, then I can write the problem. Copied? Anyone reply? Students copied or not copied? My voice is audible or not, pa? Am I audible?
Yes, sir. Yes,
So
sir.
if you are copied,
Yes, sir.
okay. So now we move on to that problem. Okay, so look at this problem. Actually, here two kind of attributes are given, gender and their nature of work. Okay, so that is a given in the problem. So the following table gives the classification of 100 workers according to the gender and the nature of work. Test whether nature of work is independent of the gender of the worker. Okay, so two kind of attributes. One is gender. Okay, another one is nature of the work. That nature is categorized as skilled and unskilled. Okay, so therefore we have two attributes. So therefore, is there any association between the gender and nature of the work? That is the question asking. So test whether nature of work is independent of the gender of the work, which means that is there any association between gender and nature of the work? Okay, so clear pa? So in that situation, which test you are going to apply? That becomes chi-square test of independence of attributes. Okay, clear pa? After reading that statement, which test you are going to apply? So we have two kind of attributes. One is gender, another one is nature of work. Okay, so the question asking is that the two attributes are whether it is independent or not independent. That is the question asking. So in that situation, so we are going to apply chi-square test. Okay, clear? All are sleeping, Aya? Huh? No one interacting me. Students?
Sir, writing, sir. Writing question.
Okay, okay, okay. Just 10 to 15 minutes. Easily we can complete that portion.
Yes, sir. Done, sir.
Yeah, done. Okay. Actually, you can prepare the total actually before moving that calculation of chi-square value. So that will be you are considered as A. That will be considered as B. Okay. So this will be considered as C. Then this will be considered as D. Okay. Now you are putting the total here. Okay. So here also you can putting the total. Okay, so what you have to get? A plus B, that is nothing but 40 plus 20, 60. Okay, C plus D, what you have to get? 10 plus 30, that becomes 40. Okay, next one, A plus C, 40 plus 10, that becomes 50. And B plus D, that becomes 20 plus 30, that becomes 50. Then total of either you can put a row wise or column wise. That is the thing. N equal to A plus B plus C plus D. So therefore, what you have to get? 50 plus 50, that becomes 100. Either you are computing the total either row wise or column wise, both are same. So that becomes 100. Okay. So now your data is over. So your computation. So now you can set up your null hypothesis and the alternative hypothesis. So null hypothesis is what you have to your null hypothesis H naught. The two attributes are what are the attributes? Gender and the nature of the work. So two attributes are independent. Okay. Next you can fix your alternative hypothesis. So H1, so that is nothing but not independent. So now you can fix your level of significance, that becomes 5% level. Okay, so now you are computing your test statistic. Okay, you can write the formula N equal to AD minus BC whole square. So divided by, you can put A plus B, C plus D. Then you have to write A plus C and B plus D. in that way you are computing your chi-square value. So now you can put everything here 100. Okay, so AD minus B square. Now you can multiply this one, AD 4 into 3, 1200 of minus BC 20 into 10, 200. So 1200, 200 minus whole square divided by here 40, then 50 into 50. Okay, so what is your value? Sorry, students. Okay, but what is the value, pa? Hello, my voice is audible, pa?
Yes, sir.
Yes, sir.
Okay, pa. So what is
Yes,
your calculated value here after computing this? Anyone tell the answer? Anyone completed up? What is the answer? So AD minus BC whole square, then you can put everything here. What is the answer, pa?
15.04.
15.04. So you can check it one more time.
10 upon root 6.
What's the answer, pa?
10 upon root 6.
10 upon root 6, you can convert it to decimal. This is the answer. 16.66. That answer is correct or not, pa? You can check it. So answer correct, pa? So this one is the correct answer, pa. So are you getting that answer? Dinesh, Dinesh, number 10.
Yes, sir. 16.67.
Oh, okay.
Correct.
So that, okay. So this one is 16.66. Now look at your degrees of freedom. Okay. So what is your degrees of freedom? M minus 1, N minus 1. Okay, that is your degrees of freedom. Okay, m is nothing but number of rows, 2 minus 1 and 2 minus 1. Okay, so therefore 1 into 1, that is nothing but 1. So now look at your table value for 1 degrees of freedom at 5% level. Okay, so look at your table value. I thought it is. So I have shared the table now. Okay, anyway, no problem. So there is no time. So this is your table value for looking at 1 degrees of freedom for 0.05. Okay, so this is your calculated value. Okay, that is your table value. Okay, so therefore your calculated value of chi-square is greater than the table value of chi-square. So therefore you can reject your null hypothesis. So that is your decision. Okay, so in that way you are computing your calculated value and table value. So this one is clear for? Any doubt?
Yes, sir.
Okay, so for the same problem we have to apply another method. Okay, so that the another method, it is suitable for either we have how many rows are given or how many, that is doesn't matter. Okay, so the same problem I have to do in the another method. One column you prepare observed frequency, another column expected frequency. Then okay, so but 2 by 2 now you can use that shortcut formula. So we can do in the another way also. So suppose we have 3 rows 3 columns, 4 rows 2 columns, that means 3 rows 5 columns, that is doesn't matter. Okay, so your m cross n, so we have the matrix is here, the matrix n cross n, particularly your n value is 2. Okay, so therefore 2 row and 2 column. Okay, so how to compute? It is suitable for any rows, any number of rows or any number of columns are given in the problem. That is doesn't matter. Okay, same answer you are getting. You don't worry about that. Okay, how to prepare that calculated value of chi-square? One column you can prepare your observed frequency. Another column you can find out your corresponding expected frequency. And third column you can prepare observed frequency minus expected frequency whole square, that divided by expected frequency. In that way you can prepare. Okay, so how to prepare that expected frequency now? Okay, first you have to write your observed frequency. Okay, so what are the observed frequency? 40, 20, 10, 30. You can write here 40, 20, 10, 30. Okay, first you have to list out the given observed frequency. Now you have to compute your expected frequency in that way. Okay, but actually how to compute that now? So this 40, okay, first you have to computing the expected frequency of this observed frequency 40. Okay, so that 40 presenting in that row total is what is that? 60. Yeah, that's 60. That 40 presenting in the column total. Okay, so 60 here, 40 presented in the row total, that value presented in the column total, 60 into 50. So divided by the grand total. What is the grand total? That becomes 100. What is that value? Okay, next you can compute 20. Okay, so 20, so that 20 presenting in that row total is 60. That column total also, that 50 divided by 100. In that way you can compute. Next one, 10. Look at this one. So 10 presented in the row total is 40. 10 presented in the column total is 50. Okay, so for example we have A, B, C. For example 3 columns now, you can addition, in addition that one more thing is there. Okay, so therefore 40 plus 20 and again 1 over. So you can add, so you can put it row total, don't consider this one is A, this one is B, C, D. Don't consider. You can put row total and column total. Don't consider that one. This is a grand total. Because we have 3 columns now, we have A, B, C, D, E, F. Okay, so no need to compute it. So you can put row total, column total, then that is your grand total. In that way you can consider. So now you are 10. What is your row total here? Presenting that 10, your row total is 40, column total is 50. 40 into 50 divided by 100. Next one 30. So 30 presenting in the row total is 40 and column total also 50 divided by 100. So in that way you can compute. So any doubt for computing that expected frequency? If you have any doubt for computing that expected frequency, it's very simple. You can put a row total and column total, then finally you can put grand total. If you want expected frequency of this one, that row total then column total, multiply that row total and column total value divided by the grand total. That 20, you can look at the row total 20 presenting that row and column total, that will be divided by the grand total. Okay, but any doubt for computing your expected frequency? Students?
No, sir.
Okay, so now you can list out your expected. What is the answer for expected frequency? I thought it as this becomes 40 means. What is the answer, Pa? 40 na 30 ya? That become 30 ya? Here that is also 30. Next one 10 na? What is the answer? 10 means 20 20. Okay, so now compute your observed frequency 40 minus 30, 10 squared. Okay, 10 squared divided by 100 by 30. Okay, so what is the value? Observed frequency minus expected frequency. What is the answer? 40. I thought it as 3.33 and 20 means that is also 3.33. Okay, and 10 means 5.00. That is also 5.00. What is the answer for final one? 16.66. You are getting the same answer.